Okay, so question one, I'm going to model kind of the writing that I expect to see when you complete the work that you're going to turn in for AP Classroom stuff. So water in a river moves uniformly to the east with speed VR. So I've got VR. Boat on the river starts from the south edge and the boat's motor gives the boat a constant speed of VB. So this sounds like it's going to be a relative motion problem, so I'm going to do that. The width of the river is W. When the boat reaches the north edge of the river, it has an eastward displacement of delta x, which of the following expressions is equal to VR. Okay, so it's not a relative motion problem. Otherwise, they would have asked for net velocity. And so instead, it sounds like it's just a normal motion problem. And so I know that the velocity of the boat is going to be W over T. And then velocity of the river is going to be delta x over t. It's the same t. And so I think that when I look at my answers, none of them have t in it. So I just need to solve for t on the boat. So I know that t is equal to w over velocity of the boat. And I'm going to substitute that in there. The arrow I would not do on my work, but everything else I would. So this is delta x over w over velocity of the boat, and then delta x vb over w. And so that is C. Okay, question 3. A block is released from rest at the top of a rough ramp. So it goes down. Oops, sorry, block. There's significant friction between the block and the ramp, but the block speed increases as the block slides down the ramp. Okay, so I know V top is less than V bottom, speeding up. Which of the following correctly indicates whether the total mechanical energy of the block earth system, not including the ramp. So I've got LOL, block earth. Anytime they say mechanical energy, I know that we're looking at an LOL chart. So I've got at the top of the ramp, I've got kinetic and UG. And at the bottom of the ramp, I've got kinetic. And then I know that I have ETH. We're going to say we're at the bottom of the ramp. So we've got no UG. This. I've got this. Kinetic is faster. I know that the total energy has decreased because of this ETH, and so total energy is decreased. So even though it's speeding up, because I have money or energy going into my thermal account, the total mechanical energy is going to decrease. So, okay, pulleys X and Y are each attached to a block by a string that wraps around the pulley. Both blocks are released, have the same linear acceleration A. As the blocks fall, the pulleys rotate about their centers. Pulley A has a larger radius than pulley X. How does the angular acceleration AX compare to AY? All right, so I'm just going to, again, this is how I would write it out. I've got AX is equal to alpha X RX. And then I've got AY is equal to alpha Y RY. These are equal, but this is bigger, which means that AY has to be smaller compared to the top. So I know that alpha X is greater than alpha Y, okay? All right, in a controlled experiment, engineers test a firecracker. The firecracker has mass M and is placed at rest on a horizontal surface. When the firecracker is lit, it explodes, breaks apart in 2 pieces. All right, so I'm gonna just draw that's state 1 and then state 2. First trial, one piece with mass M2 moves to the left with VL and the other piece moves to the right with VR. So I know that M over 2 VL is going to be equal to M over 2 VR. And the reason why it's M over 2 on the right side is because each side has gotten a half. So then we have a second trial. We have 3/4 m, and again, moving at VL, that means we have 1/4 m, because that's what's left over, and this is just times V, which is an unknown. So I'm solving for V, so I'm going to divide both sides by m, those cancel, multiply both sides by 4, so those cancel, so I have 3 times VL is equal to V. And I know that VL is equal to VR from this top part. Again, I would not put the arrow on my work, and so that means V is equal to 3 times VR. All right, that's it.